Okay, now we want to start with y equals the sine of x again, and we're going to consider now y equals a sine of x. Now actually it's not really mysterious what's going on here. When I multiply a function outside by a number, I'm either going to stretch, shrink, or if the number's negative, reflect across the x-axis. But I'll do all these things vertically. And the absolute value of a is called the function's amplitude. Okay. So, this is fairly straightforward. If I have, y equals 2 sine of x, I start with my graph just of sine. Okay, so here's my graph of sine. There's one period. And I can extend this, right, both ways. Here's pi. Here's 3 pi over 2. Here's 2 pi. So this would be 1, negative 1. Now, what's going to happen to my y values here? Well, my y value at this point is 0, and the thing is then 0 times 0, 2 is still 0. But here, at pi over 2, sine is 1, so 2 sine pi over 2 is going to be 2. So I'm going to be up here now at 2. Now I would see this as well if I made a table here. I'm going to be increasing up to here, and then I'm going to decrease, and then instead of going down to negative 1, we'll go down to negative 2 here. Right? So 3 of my 5 points of interest stay the same. These other ones are stretched. Okay, so that's a stretching. What if I have, for example, y equals 1/3 sine of x? Okay. Then what? Then again, I start with my sine function, right? Like so. So there's one period. But now my y values are going to be shrunk by a factor of 1/3. So I'm going to be up to 1/3, down to 1/3, right? Negative 1/3 for these 2 points, and all the other points are the same. So this is shrinking here. Now, it might seem to you a bit unfair with the previous video is that it was the opposite. When we were multiplying through by 2, for instance, when we had sine of 2x, it actually shrunk horizontally. It didn't stretch. Why are we stretching vertically here? It doesn't seem right. Well, the reason is that my 2 here is on the outside. And so this is something that we might note here, is that we can write y equals 2 sine of x as 1/2 y equals sine of x. And if I write it in this fashion, it's not so mysterious that we're doing the opposite thing of what you might think. Okay, finally, if we have a negative value, that's going to reflect about the x-axis. If I have y equals negative sine of x now, just think, all my y values are negated. And when I negate a y value, I flip it across the x-axis. So instead of being up here at 1, we're going to be down here at negative 1. And then, so that's that point. And then over here, instead of being at negative 1, we're going to be up here at 1. So my y equals negative sine of x, just in general, is going to look like this, right? and so on. So you have to use your imagination here a little bit in order to do that. What we might do is combine this with our previous one, and we'll do that in the next video.